Hi, I'm Philippe Coval and I will share some experiments about the digital twin today. So who am I? I'm a software engineer from Brittany in France and I'm currently working as an open source contributor as a Mozilla rep on IoT projects. So I've been involved in the past in open source software for the industry, mostly on embedded development like Tizen operating system, Yocto for automotive, and IoTVT or CF when I was at Samsung. So you can contact me at this address perl.org/rzr, and I'm available for any cooperation or opportunities. So you can also check some previous presentation on related subject and video and social media and so on. So what are digital twin? This can be defined by this very short definition. It's a digital replica of a physical entity with a connectivity between the pair. So once one is changing, the other is updated. And at the same time, once this other one is been changing, it should reflect to reality. So we have a kind of seamless interaction between the device or its model, and we can use like a shadow object if the objects are disconnected, and we can also use this shadow object as a proxy to the actual thing to update some properties. And of course we can view this 3D object in a simulation, and you can visualize this in a VR environment or augmented reality. So that's not something new because it was introduced in the year 2002, and actually a couple of years earlier I act some kind of puppet show on the internet using sensor and VRML plugins. But today it's more easier than it used to be in the past, so I will introduce you with this concept. So I have this robot and I can control each motors of it, and it will update the robot here. So this is a clue. I'm changing the angle of the motor for the hand and it will open. And at the same time the 3D model is updated at the same time. So you can create some kind of smart behavior between the device, like this using WebThings rule engine. I can update some properties of the robot. So when I'm pressing this approaching button, I can move the shoulder to 45 degrees and the arm to minus 45 and turn the light on. And at the same time I create another rule which is doing exactly the same thing but in the opposite direction. And when I press on my WebThings dashboard button, like this robot approaching button, it turns on the light as we saw, and the robot is moving in reality and in the simulation. And I have this extra sensor on the claw on my robot, and if I'm changing the color of my light from red to green and look back to the sensor, it's updated as greenish. So we have these behaviors. So I can also control from a VR environment all the dashboard using 3D element like this switch, and I can toggle it on and off just like I did before. It will update the actual robot and the 3D model, which is a simplified version. So how can digital twin can be used? So it's very wide because we have some kind of device as a service concept. So even if the device itself is not yet created, you can design it and simulate it before you have it created, and then you can deploy to an actual place. And if there is some issue, you can record and play back what has been done. So that's one use case, and the other is remote controlling. That's what I've been doing just before. So this can be really helpful in a lockdown situation when you can get access to your machine. And this is useful for impact analysis and improve decision making, and it's part of the product life management. And so this can be used in many different domains from the industry. So we can imagine a production chain when you have different robots working together, and if you want to see if they are getting along and they are not conflicting themselves, you can do a simulation first and try to see if something can be optimized without stopping the production. It can be also been used in city when you want to have real-time visualization about the traffic in the city or the buildings. And you can use also robotics, as I shown, and interaction with humans like cobotics, and it can be used in different areas. I know there is some 5G experiment using digital twins. So there is many use cases, and you can check what the W3C is trying to describing at this moment. While we're here, I want to speak about some ethical consideration, and I want to remind that in Europe, the GDPR regulation is trying to promote system to be handling privacy by design and by default. So that's an opportunity for open source software because privacy is part of our community DNA. So the challenge we have today is, can we create some digital twins with privacy in mind and to have something which is user data centric and decentralized to be more resilient. So here I'm going to introduce the web because I believe it's a platform for creating this kind of scenario. So the web has been created for interoperability in mind. It was built on open standard and free software also, and it's decentralized just like it was the internet at the beginning. And the browser itself is providing a trusted environment for isolating application. Of course, the web is programmable. You can use a REST API for interacting with web services. And if you need some real time, you can use a WebSocket technology also. And for UI and UX, we have a lot in 2D world using HTML, but also now we are targeting the 3D world using different API like WebGL to access GPU for virtual reality, and augmented reality is part of this extended reality. So I will show a couple of frameworks I've been using, and also let's mention about IoT because there is a working group at W3C which is trying to propose some standard for dealing with actual things on using the web platform. And one open source implementation is Mozilla WebThings. So it's a platform where user can control all the devices in his home, and you can control them from the web using a URI dashboard and create some kind of automation using rules. That's what I've been shown just before. And the platform itself is extensible with add-ons, so you can support new protocols or new services or use some kind of new device or radio protocol, whatever you need. There is no limit to this. And for the record, it has been inspired by the Web of Things work and the simplified things description using JSON schemas. So privacy is one of the key feature of this WebThing platform because all the devices are connected together inside the user LAN. So each of them is a server connected to the gateway which is giving access to the user. And the data stay at the edge, so there is no cloud involved because the dashboard is running on the gateway itself. And all device resource can be also shared to other applications in a safely way using JSON Web Token and REST API or WebSocket. And if you need to get access from the internet, it's also possible using a tunnel provided by PackageKite. So for the UI, we saw the 2D dashboard, which is actually SVG, and for creating 3D application, it's also possible in a virtual reality or augmented reality, and now we are talking about extended reality. So that's another word for 3D rendering in a browser using different framework and handling some device sensor. So on a headset, for instance, you have some orientation sensor where you can update the view. So everything is handled by the A-frame framework I've been using, which is based on 3GS and which is based on a WebGL API, and in the end it is running on the GPU, so you have a decent performance. And the scene graph is made of different models that can be parameterized, and from the document object model you can access each element in the scene, and you can, for instance, target one object and change the rotation using the 3GS object API. And you can also describe your device using a higher level API using JSON schema. So for instance, we are not talking about a rotation, but let's say we are modeling like a a compass. It's just an angle which is indicating the direction of the north. So the next step now is to bind what can be measured in the real world from IoT. So we have, let's say, a compass sensor, and we can bind this to an XR environment. So I've been doing this with using a web component, and while I'm here, I can show you another demonstration using Mozilla Hub. So Hubs is a social platform where you can connect together and make some chat room in a 3D environment. So it's running on a browser or mobile, and you can move in this environment just like if you were in a computer game, and all device, all clients are sharing the same environment, and they are updating at the same time. So I'm updating here my position on the phone, and it's updated in a 3D world at the same time. But it goes beyond that. So I created this 3D model which is a replica of my this small house prototype. And when I'm moving it in the real world, it will be updated also in the 3D environment. So how does this work? So I have here a Raspberry Pi with a couple of sensors. So we have the control at on this corner of the screen when I have different sensors like an accelerometer, a gyroscope, and a magnetic sensor. So I'm measuring here the value, the angle to the north, and if I'm moving my box, it will slowly converge to the north direction. So this is a WebThings dashboard, and I have different elements I can control from it. Like I have also other sensors on this board, like humidity, pressure, temperature, and also a joystick where you can move in different direction. It will trigger events and update this add sensor. And as you can see, there is a matrix LED where I'm indicating the north direction, but I can also control all the LED, change the colors of them. Let's move to, and also I can use this message property, and if I'm changing it, it will display hello from OW2. So I made the sensor add-on for this WebThings sensor hat for Raspberry Pi. So if you want to get started, there is a simple example which is a simulation, but it's also working on the actual device. So I'm trying to indicate the value of a sensor of a solar panel, and I'm changing the color of the solar panel on the roof of my model, and it's matching the voltage level. So that's something you can use as a simulator also. I have it running on a microcontroller on a STM32 board using IoT.js, but you can use this on a Node.js. It's quite easy to get started. So what you need to understand, so once you are including the WebThings bindings to A-frame library, then you can insert into your document a GLTF 3D model, and then you can bind one property of, so here this is the solar parts, which is part of the house model, and it's connected to the WebThings which is at a given address. So here it's a local address, but you can use a device address or the gateway address. So this needs to be updated. So here I'm sharing also some additional resources. You can get access to the source code, and if you can give me some feedback about how can I move this project forward, or try to make it bigger for any different use case, and also sponsorship is welcome. Feel free to reach me on these addresses, and if there is any issue, I really appreciate if you can report them. So thank you for everything, and now I'm open to any question. If there is any, you can also reach me online.